Hey, this is Mr. Mitchell. Today we'd like to talk about conservation. Conservation is protecting, restoring, and managing natural resources as long as so they can last as long as possible. And there's some things we can do to conserve, and you can see them right here, and they call them the 3 R's. You may have seen the recycling mascot, Riri, reduce, reuse, recycle. And most people generally think it's easier to start with reducing and reusing. And then when you are in the habit of that, then you can probably do some more update stuff like recycling. Uh, Lots of things you can do for reusing and reducing. You could reduce the amount of electricity you use. You could reduce the amount of the water that goes down the drain pipe. You can reduce or reuse plastic bottles. You can reuse old clothes. You can reuse old storage bags. You can recycle things like glass, things like cans, things like plastics. Lots of different ways that you can do your part. Now, not every item in our trash can be recycled or reused. In fact, probably some estimates have only about a fifth of what our trash is can be recycled or reused, but that is something that can help. Now, what we have to do is to look, well, before we do that, here in Rome and Floyd County, we actually have a recycling center, and I have right up here RomeFloydRecycles.org. I just took a picture of their page, and you can see it happens to be on Water Street, and there's lots of different things that are accepted. You can see materials accepted, tires, computers, lots of different things right here. So that if you get to the point where you can recycle, this is definitely a place in which you can look at. Okay, now that we've talked a little bit about conservation, I want to talk a little bit about alternate forms of energy. You may remember that there's only so far that fossil fuels can go. Fossil fuels are supposed to run out either in your lifetime or in your children's lifetime. But before we look at the alternate forms of energy, I want to remind you how fossil fuels cause electricity. The burned fuels, and in this case it's coal, the burned coal produces intense heat, which leads to boiling water, which produces steam. The steam in the generator turns the blades, and the turbine creates energy. And using coiled wire and a magnetic field, the generator that the turbine turns the blades to make it move creates electricity. So, heats the water, makes the steam, turns the turbines into the generator, creates electricity. And here's another way of looking at it. You've got the heat source here, which is the coal being burned, which could be something else in alternative energy practices. Heats the water, steam goes up, turns these turbines. We have extra waste coming down here. The turbines move the generator, which produces the electricity because of the magnetics and because of the copper wiring. So, what does a generator look like? Well, this is a big generator here. When you talk about producing electricity for lots and lots of people, these are the kind of generator that you have, and you can see this is where the turbines would be, the mass, huge area of twisting things, twisting metal and so on, and then that's where the generator would produce other stuff, produce the electricity. Okay, one of the alternative forms of energy is nuclear fission, and nuclear fission works similar to fossil fuels. What nuclear fission does is it gets energy from a different source, from a nuclear source. Scientists have found out if you take uranium, this is an atom of uranium, which is a radioactive material, and you separate it. Now, this is stepping right into the heart of some deep chemistry here, but I'll try it anyway. Scientists have found that you can kind of use a neutron as a battering ram. that they can send the neutron into an individual atom of uranium, and it can burst it apart, kind of like taking a cue ball and hitting all the pool balls and busting them. Except in this case, it is just one, and it hits and it creates two different elements. But in the process of creating two different elements, it unloads a huge amount of energy. Now, the amount of energy that it unloaded, well, it's kind of like an atomic bomb, and this is kind of the process of an atomic bomb, splitting an atom and creating the energy from it. And this energy, I mean, this is a huge amount of energy, and we have found ways to kind of control the amount of energy to where it's not mass destruction. So what they've done with that energy, and they do it at plants that look like this. You probably have seen smokestacks that are big old huge smokestacks like this. Not the ones like we have in Coosa. These are much wider. This is not pollution coming out. This is where the water goes. This is where the water goes, because you have to have lots of water to be able to cool down everything after this energy has been used, has been exploded. So what happens with nuclear fission is this happens. Instead of having coal creating the energy, it's not the coal that boils the water. It is this process, the energy of the split atom, that boils the water, that creates the steam, that moves the turbines, that goes to the generator, and creates electricity from a magnetic field and coiled wire. So you can see that a nuclear fission reaction, the way of creating energy and creating electricity, is not that different from the way we do it already. So that is a possible alternative way to do things, and we already have a lot of nuclear reactors where we do such stuff. Outside of fossil fuels, this is probably the most common form of alternate energy. There are some positives and negatives to nuclear fission. Positives, wow, huge amounts of energy. You can get a lot of electricity from these places. Another positive, it's not a fossil fuel. It's not a threat to run out anytime soon. Another positive, we already have 10% of our energy coming from nuclear energy. Negatives, well, it's a big one. Nuclear fission produces radioactive waste, and you may not be as familiar with radioactive waste, but long exposure to radioactive waste causes death. And since you have this waste product that comes from here, you have to find a way to store it. All this radioactive waste cannot be left out, cannot be seeping into streams and rivers or left in the woods. This has to be stored and stored safely. So this is a good possibility, but it's just something that's really has one huge potential negative, but it's something that we have generally been able to control. Here is another alternate energy source, hydroelectric power, and this is something that we use now. It involves using a dam. Now this dam will be across some sort of big river. It actually creates a lake or a reservoir. We have one of these at Weiss Lake over in Alabama. But what happens to create their energy? You use flowing water. You use flowing water. And this flowing water, you can see it has to be a high-level lake, and then it goes down to a low-level river. And what that happens is that causes downward flow of water. This is like a waterfall. And you see the energy that can happen with a waterfall with a downward flow of water. And you see what it does. It turns the turbines, which causes the electricity from the generator. So that's how water produces electricity. So kind of as a result, we're not using boiling water. We're not burning coal. We're using running water to spin the turbines, to make the electricity, and you still have the coiled wire and the magnetic field. And that's something that's fairly commonly used, even though it is a very small percentage, well less than 10% of all the energy we have, But we do have dams at many rivers, especially here in the South, that do create electricity this way. Positives and negatives. Positives to hydroelectric power. Hey, no pollution. And it's not a fossil fuel. There are a couple of negatives. To make these big rivers, to make these dams, you have to relocate people and animals to build the dams. If you build whenever this lake over here in Alabama was built, Weiss Lake, there were a lot of people who lost their land, lost their homes, because the lake was going to be there. So a lot of people will lose their land, and that won't be very popular. Plus, it's costly. But environmentally, it really is a good alternative to fossil fuels.